United Nations have finally the 70 Sustainable Development Goals with a view to ensure positive global development occurs economically, environmentally and socially. Zero hunger is the second goal. By 2050, the world's population will reach 9.7 billion people. That's a lot of people to feed. Current farming methods will not suffice, as right now 720 to 811 million people go hungry every day.
Our collective of researchers from Newcastle University and Urte University have explored the feasibility of large-scale offshore agriculture to help tackle these issues surrounding world hunger. The Netherlands have achieved great success with their highly efficient and sustainable greenhouses, producing 80 times more crops whilst using 4 times less water, becoming the world's second greatest food exporter. But these greenhouses still require large land areas. As the demand for land increases to accommodate for growing populations and to protect our ecosystem, the prospect of creating land becomes a necessity. Offshore agriculture offers a solution by moving greenhouses offshore to deploy in areas where they are most needed, increasing sustainable crop production, ensuring food security and saving valuable land for future generations.
But how did it work? The research carried out in this collective involved an in-depth technical analysis and critical review. Stability and dynamic performance analysis was completed to better understand the structures the greenhouse will operate on and how they will be secured offshore. The power and water demand for the platform was considered, plus a general arrangement and the final design were produced. A green energy hybrid was proposed to help reduce the reliance of the platform on well-established grid connections. The farming method was also explored in more detail.
Aeroponics is a farming technique that uses no soil and up to 90% less water than its in-soil counterparts, or hydroponics. Aeroponics is essentially a farming system that suspends the roots of plants and has a constant flow of a mist-like water source that has a lot of nutrients in it. In the aeroponic system that we are going to use in offshore are LED lights to make sure that the plants get enough UV light so that they can photosynthesize. Number 2 is the constant flow of mist. And number 3 is the innovation. We are going to stack the aeroponic systems one on top of each other to capitalize the little space that we have. Another very important aspect of the aeroponic techniques is these little buckets. Essentially what this does is it allows the roots to be accessible to the nutrient mist and helps in absorption, making sure that the plants get the nutrients that they need. The aeroponic system that we are going to use is very lightweight, making it perfect for offshore farming.
Great stuff, guys. The findings of this study provide a strong case for the feasibility of offshore agriculture. If funded by a government or an international body for food relief or food security, the concept proves extremely viable. Further research into each area assessed is required. However, the premise for a semi-submersible platform that facilitates large-scale offshore agriculture is provided.
This is the future of farming.